Hey everybody, this is Dr. Andrew Asadolahi, and in this video we are going to be discussing the substitution method for solving systems of equations. And specifically, we're going to look at one example of a system of two equations with two variables. So to get started, let's discuss briefly the background information of the substitution method for solving systems of equations. So basically what you want to do is you want to solve for one of the variables in terms of the other variable or variables in one of your equations. So again, when you have a system of equations, maybe you have two equations with two variables, or maybe three equations with three variables, whatever the case may be, you pick one of the variables and you rearrange one of the equations so you solve for the variable you picked in terms of the other variables, okay? So you start with one of your equations in your system, solve for one variable in terms of the other variable or variables, okay? And then what you do is you substitute that rearranged equation into the other equation or equations, depending on how many you have. Okay, so that's it in a nutshell. That's basically the methodology. Now let's jump right into an example and test this out, okay? So let's start with an example, okay? And we are going to say given. And in this given information, we're going to be told to solve the system using substitution. Okay, and so let's start out with a pretty simple example. X plus y equals 3, and then x minus y equals 1. All right, so here's our system. If you notice, we have two equations. We can go ahead and label them. We can call this equation 1 and equation 2. And we have two variables. Our two variables, of course, are x and y, and we see both equations contain both variables. So let's go ahead and write solution now. So according to our little process, we solve for one of these variables in terms of the other variable in one of the equations. Now, what's great about it is it does not matter which variable you start with and decide to solve for. So I could solve for x in terms of y or y in terms of x. And it also doesn't matter which equation you choose to use to get the process going. You could start with equation 1 here or equation 2. For this example's purposes, let's just start with equation 1 and let's solve for x in terms of y. So I'm going to say, let's solve for x in terms of y in equation 1. Okay, so looking at equation 1 right here, what I'm going to do is I'm going to rearrange it and I'm going to say x equals negative y plus 3. Okay, so I've done the first step of my substitution process. I solved for one of the variables, in this case it was x, in terms of the other variable, and the other variable being y, and I did that using equation 1 right here. And then what we do is we substitute this into equation 2. So this is the second part of our process. We substitute this rearranged version of equation 1 into equation 2. So if you want to, you can keep the label here. This is still equation 1. It's just rearranged. So here's what we're going to do now. We're going to substitute that into equation 2. So in equation 2, where we have an x, we are now going to write negative y plus 3, okay? So in equation 2, we now have negative y plus 3, and that has been substituted in for the x value into this x term from equation 2. And then, of course, we say minus y equals 1, okay? So again, how have we done this? Well, again, we have taken this rearranged equation 1 because we're saying x is equal to negative y plus 3. And so we're substituting in that negative y plus 3 into the x variable that's in equation 2 here. But still, don't forget, you still have the minus y equals 1 because we're still, at this point, operating inside equation 2. So I can make a note here, this is equation 2, just with equation 1 substituted into it. Now, if you look here, what do we have? We now have one equation, which is our equation 2, with only one variable y. So I can make a note of that here. We have one equation with one variable. And that variable, of course, is y. And so that's an easy solve now, right? We say minus y, so that gives us negative 2y plus 3 equals 1. And then, of course, we have negative 2y equals negative 2, y equals negative 1. Okay, I'm sorry, y equals positive 1. What am I thinking? Y equals 1. So that is part of our answer, but we are not quite done yet because when we solve a system, we have to solve for the ordered pair, an x value and a y value that satisfy both equations. So now what we can do is we'll say now substitute y equals 1 into either equation 1 or 2 to solve for x. So now what we're going to do is we're going to take, we know that y equals 1, we're going to substitute this back into an earlier form of either of the equations and solve for x. So how about we use this rearranged version of equation 1, but again, you could substitute that y value into any of the earlier versions of either equation you're dealing with. It just is pretty convenient to substitute it back into this rearranged version of equation 1. And so to solve for x, we would just say x equals, and of course here it says x equals negative y plus 3. So we would have x equals negative 1 plus 3, and we see x equals 2, okay? So the solution, our solution to our system is the following. The system's solution is x equals 2, comma, y equals 1. And another thing to mention about this is the values of the solution satisfy both equations in the system. And what we mean by that is that if you substitute x equals 2 and y equals 1 back into both of your starting equations from the beginning of the problem, both equations would hold true. So you can check that out on your own, okay? And finally, using some vocabulary that I discussed in one of my other videos, we can also say the system is consistent. Remember, a consistent system has at least one solution, okay? So that concludes this video. Please hit like and subscribe.